Hello friends, so we are here again with another question on KVL and KCL application. So the circuit diagram is given and we have been asked to find the current drawn by this ammeter which is connected here, and it has been given that we assume negligible voltage drop across the ammeter. Okay, so we have redrawn the circuit here. So first let us assign the branch currents. So here there are two branches, 30 ohm and 5 ohm, across which the ammeter is connected. Let's say the current flowing through this is I1 and this is I2. So here if we apply KCL, the current supplied by this 9 volt, this will become I1 plus I2. Polarity will be like this, plus minus. Here I1 flowing through 30 ohm in this way, plus minus. This is plus minus. And let's say the voltage drop is VA, which is equal to 0 volt given. Okay. And here the same current I1 plus I2 as is supplied, it flows back like this, plus minus into the negative terminal. So now we just have to apply KVL in both these loops to get the result, whatever we are trying. We are trying to find this I2 current flowing into the ammeter, I2. That is our objective. So let us do that. So let us write the KVL equation for this loop, first loop, KVL equation 1. 9 volt minus 10 into I1 plus I2, I1 plus I2 flowing through this 10 ohm, then minus 30 I1, positive to negative, I1 flowing through 30 ohm, then minus 5 into I1 plus I2 equals to 0. This. That implies 9 minus 10 I1 minus 10 I2 minus 30 I1 minus 5 I1 minus 5 I2 equals to 0. That implies 9 minus 45 I1 minus 15 I2 equals to 0. That implies, bringing them to one side, 45 I1 plus 15 I2 is equal to 9. That is, let's say, equation 1. Then we'll apply KVL in this second loop, okay, like this, KVL equation 2. KVL 2, it will be 30 I1, we are going from negative to positive, second sign is 30, I1 flowing through 30 ohm, minus 5 I2 minus VA is equal to 0. VA is 0 volt, negligible voltage drop across the ammeter that is given. That implies 30 I1 minus 5 I2 is equal to 0. That implies 30 I1 is equal to 5 I2. That implies I2 is equal to 30 by 5 I1, which is equal to 6 I1. I2 is equal to 6 I1. This is the second equation that we have got. So if we substitute this in 1, substituting 1, equation 2 in equation 1, we get 45I1 plus 15 into 6I1 is equal to 9. That implies 45I1 plus 15 into 6 is 90. 90I1 is equal to 9. That implies 135I1 is equal to 9. That implies I1 is equal to 9 by 135 ampere, which is equal to, it is coming around 0.067 ampere. So here I1 we calculated as 0.067 ampere, that, and I2 is equal to 6I1. Okay, here we got, so I2 will be 6 multiplied with this much, and that is coming around nearly 0.4 ampere. 6I1. So this is the current flowing through the ammeter, drawn by the ammeter. This is the result that we wanted. So this was again a very simple question, straightforward application of KVL and KCL. So first step, assignment of branch currents. Second, assigning the polarities. Then application of KVL. We got two equations. Then we substituted one equation in another and we got the result. Okay. Hello friends. So this is another question on KVL and KCL application. So here we have this circuit diagram, and it has been said that the current in this branch OA is 0, and we have to find the value of this unknown resistor, this resistance R. Okay, so here we have redrawn the circuit. So now we have to assign first the branch currents according to our choice, and then it will be simple application of KVL and KCL like all the previous cases. Okay, so let us say this current, let's say it is I1, let's say this current is I2, and let's say this current flowing through this branch OA is I3. Now here I3 is equal to 0 ampere. This is given in the question. The current in the branch OA is 0. So this is I1, this is I2. Here this current is I1. Here as I3 is flowing, this will be, let's say, I1 minus I3. This is I1 minus I3. And here it is I2, here is I3, so they will get added up, and it will be I2 plus I3. Okay, this is I2 plus I3. So here it is I1 minus I3, here it is I2 plus I3, so this is I1 plus I2. Okay, see how KCL is applied, Kirchhoff's current law, okay, at each node, at each point, each junction. So I think all the branches have been covered, all the branch currents have been assigned. Yes, this one, yes, everything is covered. Now second step, important step, assignment of the polarity, the voltage drop of each resistor. Current always flows from positive to negative. So here this is plus, this is minus. Here current is flowing in this direction downwards, so it is plus, minus. Here current is flowing in this direction, so this one is plus, this one is minus. Current is flowing in this direction, plus, minus. Current is flowing in this direction, plus, minus. Okay, polarities have been assigned. Now simple application of KVL. Now we have to apply KVL. Okay, so First, let us consider the loop B O A B. Okay, B O A B. This loop B O A B. This left side, upper left side, B O A B. Okay. So KVL in loop B O A B. So that will be, here also I have missed the polarity. This is plus minus. Okay, let's use the red color so that there is no confusion. This is plus minus, this one is plus, this one is minus. Okay, that I missed. Okay, KVL in loop BOAB. So here it is minus 4I2 as we are moving from plus to minus, plus 480I3, okay, as we are moving from minus to plus I1, 1 into I1 as we are moving from minus to plus. I am using the second sign dominating method, okay, that is equal to 0. Now I3 is equal to 0, so this entire term will become 0. That implies minus 4I2 plus I1 is equal to 0. That implies I1 is equal to 4I2. So here we have got a current dependent relationship. This is very important. Okay, this is, let's call it equation 1. Okay. Now we have considered one loop, we have applied the KVL, and we have got an important relationship. Now let us consider loop, okay, OACO, okay, this right, upper right side, OACO. So let us apply KVL there. KVL in loop OACO, that. So here if we want to apply KVL, here it will be, let's start from this C point, it will be plus R into I2 plus I3, okay, first R into I2 plus I3, then plus 480 I3 plus 480 I3. Why I am putting plus sign? Because we are moving from minus to plus sign, okay. Then minus 1.5 into I1 minus I3, minus this one, minus 1.5 as we are moving from plus to minus, minus 1.5 into I1 minus I3, summation is equal to 0. Okay, so now let us just simplify it, bring it into simple form. So it is Ri2 plus Ri3 plus 480 I3 minus 1.5 I1 plus 1.5 I3 is equal to 0. Again, important relationship, not relationship actually, it is given I3 is equal to 0. So every I3 term, containing term will be 0. This will be 0, this will be 0, this will be 0. So now we are left with only Ri2 minus 1.5 I1 is equal to 0. This is, let's say, the second equation. So now we have two relationships. First, I1 is equal to 4I2 and Ri2 minus 1.5 I1 is equal to 0. So if we substitute equation 1 in equation 2, that is I1 is equal to 4I2 in equation 2, then it will become Ri2 minus 1.5 I1, which is 4I2. I1 is equal to 4I2 that we have substituted. In place of I1 we have substituted 4I2 as per this relationship which we obtained. That implies Ri2 minus 6I2 is equal to 0. That implies I2 into R minus 6 is equal to 0. That implies R minus 6 is equal to 0. That implies R is equal to 6 ohm. We have got the answer. R is equal to 6 ohm. That was asked. Okay, only that was asked. The current in the branch OA is 0. Find the value of R. Only that much is required. No need to find each of the branch currents here. Only this is the result. R is equal to 6 ohm. That was our objective. Okay. This. So here the current, the correct assessment of the question is very important. Here unnecessarily you don't have to waste your time finding out each of the branch currents. Simply pick up the correct loops to apply KVL. Like we first applied KVL in BOAB. There we got the relationship between I1 and I2. Then we applied KVL in OACO. There we got this relationship. Directly we applied it. No need to find the individual values of the current, and we got the result R is equal to 6 ohm. If it would have been asked in this question to find the values of each of the branch currents, then it would have become lengthy, because then a lot of equations would have been involved. So that is not asked here. So here if it is an objective type question in a competitive exam, there you have to use your common sense, okay, to find the correct relationships, attack the right loop, then in order to save time, minimize the number of equations that are involved, avoid unnecessary steps, and get the answer. But if it is a subjective type question involving a lot of marks, and it has been asked to find the values of the individual branch currents, then of course you have to do all that, apply equations in each loop, find the dependence between parameters, the current values, and then substitute it and get the result. But here no need of that, only the result we want to get, the value of R, we have got it, that is equal to 6 ohm.